Hello everybody, my name is Tim. I recently got my PhD in the University of Colorado in Boulder, focusing on signal integrity. I'm a signal integrity application scientist at Keysight Technologies. Today, I'm going to talk to you about chiplets. There are three things I want to talk to you about today. First, why the industry is shifting to chiplet designs. Second, what are the challenges for chiplet designs? And third, how Keysight EDA can help you with your chiplet design. Traditionally, a chip looks like this. There are four different functions in one big die, namely A, B, C, and D. In a chiplet approach, what we will see is this: four different dies with four different distinct functions: die A, die B, die C, and die D. Now this is how it looks like on the wafer. On the wafer side, we will see that since the dies are smaller, we're using the same space with the same number of defects. Let's see what happens on the big dies. Given four defects, we will see that the yield will be 66.7%. If we use the chiplet design philosophy, on the left, we will see the same four defects will give us a yield of 97.3. This tells us that the traditional approach is of a higher cost and higher risk. That's why the chiplet design philosophy is increasingly adopted now, since it has a lower cost and lower risk. Number two, what are the challenges? Yes, as we know, there are no free lunches in this world. So comparing the traditional approach versus chiplet, the challenges is the communication between the different dies. To mitigate these communication issues, various communication standards has been proposed for the chiplet communication. And today, I will focus on UCIe, the Universal Chiplet Interconnect Express. And number three, here is how Keysight EDA can help. This is our Keysight EDA Chiplet PHY designer. We'll see on the very left there, it's chiplet die number 1. And here is chiplet die number 2. We have cleverly designed the program so it can be easily connected even when there is a layout in the middle. Usually, what goes on between the dies can be modeled by a 3D EM program like SI Pro. On the bottom left will be your die 1, on the top right will be your die 2, and this is the interconnect between them. Once the 3D EM model has been captured by SI Pro, it can be put in back to the chiplet post layout component. Then we can make the connections. To make the connection, it's very simple. You will click on the wiring button, click on the die, and the interconnect. All 64 of these connections can be connected with one click. Once we've done on the left hand side, we'll do the same on the right. Same thing, one click to connect them all. And there you are, you have connected all these connections with few clicks. After making all the connections and the simulation, we do expect the eye to be open both on die 1 and die 2. Here is die 1, eye is open. Die 2, die is open. Great day for us. Today I've shown you how to use Keysight EDA Chiplet PHY Designer to set up the die-to-die connection to simulate UCIe. To find out more, go to keysight.com and search Chiplet PHY Designer. Thank you for watching.